Okay, hi guys. So from the previous lecture, we'll be continuing on seeing RPDF theory in more depth now. So let's say for 1s orbital, we need to find Rmax. Rmax is nothing but the distance from nucleus where electron finding probability is maximum. Ability is maximum. Okay. So in other words, we'll be seeing calculation of Rmax. So let me rewrite it that RPDF value, as we discussed in the previous lecture, was 4 pi r square capital R square R. Okay, and wherever d by dr value of RPDF is 0, this implies at that point maximum probability would be there. So we need to find the R where the d by dr of RPDF goes to 0, hence implying that RPDF would be maximum there. At what value of R this would be possible? Okay, in other words, this R would be nothing but R max. Okay, so let's get started. Just substitute the value of RR for 1s orbital as we are seeing for 1s specifically. So value of RR for 1s would be, if you remember from previous lectures, that the value is e to the power minus sigma by 2, where sigma is 2zr upon n a naught. Okay, so just put the value of RPDF here. So d by dr of RPDF would be nothing but d by dr of what is the value of RPDR here? RPDR is, okay, let me write it down here itself. So it is nothing but 4 pi r square or r square. Okay, so it would be nothing but d by dr 4 pi r square multiplied with 2z upon a naught to the power 3 by 2 e to the power minus sigma by 2 whole squared. So this value should be equal to 0. Okay, so I hope you remember this concept from mathematics, that for a value to be at maxima, d by dr of that value should be 0. That's how maxima is defined. So let's suppose this is the graph. So this is the point where d by dr of y, let's say dy by dx would be 0, hence y would be maximum at this point. The same logic we are applying here as well. So let's calculate the same value. So let's equate this value to 0. Okay, so now for z equals to 1 and 1s orbital, n is equals to 1. Okay, so before putting in the value of sigma, let's do some pre-calculation, that we know that sigma is, so we can directly put the values here. So we know that sigma is 2zr upon na naught. So from here sigma would be, z value for hydrogen atom is 1. Okay, so it would be nothing but 4 times of so I actually already put the value of z. So from here you can see that um, not here, we'll be putting the value of sigma here, because the only term of sigma in this equation is present in e's exponent. Okay, so we are putting the value of sigma here. So sigma would be 2 multiplied with z would be 1, r upon n is again 1, a naught. So the value would be 2r upon a naught. So let's simplify this. So it would be 4 pi r square multiplied with 2, 1 upon a naught to the power 3 by 2 into e to the power minus sigma by 2 whole squared should be equals to 0. Okay, so from here d by dr 4 pi r square, apply the square into the bracket, it would be 4 into 1 by a naught whole cube into e to the power minus sigma. The value of this should be 0. Okay, so let's just compute this. So it would be nothing but d by dr of, we have this as a 16 pi r square upon a naught cube, okay, into e to the power minus 2r by a naught. We discuss the value of sigma as, or derive the value of sigma as 2r by a naught. Okay, this would be equal to 0. Okay, so just applying d by dr of x dot y property here in the next line. So obviously 16 pi by a cube would be thrown out of the equation, just like it would be something like saying d by dr of r square, this is a naught cube, r square into e to the power minus 2r by a naught. So this is x, this is y, equals to 0. So I can just equate this to 0. So means as this cannot be 0, so not equating it, as this value is a constant c, which is constant, not equal to 0, c multiplied with some function of r. If c dot fr is 0, then this implies fr should be equal to 0, as c is not equal to 0. Hence directly equating d by dr of r square times e to the power minus 2r by a naught as 0. So we would be having first this as, so I hope you remember that d by dx or other d by dr of x dot y. So we take x dy by dr plus, what else, we'd be taking y dx by dr. So this is the form for evaluating d by dr into d by dr of x dot y. Okay, so this would simplify to, we would be having 2r times, okay, so first is x, so let's take r square out of the equation, r square, then d by dr of e to the power minus 2r by a naught plus, it would be, let's take e to the power minus 2r by a naught outside, and then it would be, what else, it would be d by dr of r square, this should be equals to 0. Okay, what is the d by dr of e to the power minus 2r by a naught? It's simply minus 2 by a naught multiplied with e to the power minus 2r by a naught plus, it would be e to the power minus 2r by a naught multiplied with r, d by dr of r square would be 2r. Hence it could be simplified or bracketed further into e to the power minus 2r by a naught. So minus 2r square by a naught plus 2r should be equals to 0. Again this value cannot be equal to 0. Okay, hence this value must be equal to 0. Just equate minus 2r square by a naught plus 2r as 0. So we would be getting something like 2r equals to 2r square upon a naught So from here you can cancel, and you will be getting R equals to A naught. Okay, and the value of A naught we have calculated was 0.529 angstrom. I have also discussed the value of A naught in some previous lectures. Hence this is R max for 1s orbital in hydrogen atom. So this value was calculated by Bohr. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing some more insights on little part of wave function. Till then, good luck and goodbye.